Okay, so we are on the first problem here, problem number 1. The event they want us to analyze is that all 5 people we choose are going to be women. Okay, so that's the event that we're trying to find the probability of. We'll call it the event E. Now, if you recall from the probability section, the probability of an event E is equal to the number of outcomes or number of ways in which the event E will occur. Divided by the number of ways in which any outcome can occur. Okay? So, let's think about what is event E. So, event E is that we're choosing 5 women. Actually, we're choosing 5 people, and they all ended up being women. Okay, so this is the number of ways to choose 5 women out of 13 women. Divided by the number of ways anything can occur. Okay, so the number of ways to choose what? What do we mean by any outcome? It doesn't matter if I get men or women. So it's a number of ways to choose what? 5 people in general of either gender out of 20 people. Okay, so now the next thing to ask ourselves is when we say choose, let's say 5 women out of 13 women, does the order matter? Okay, so does it matter what sequence I choose the women? Is the first person chosen, did they have a special role, or is it just any 5 people? And the answer is it's any 5 people, right? So in other words, the order does not matter. Okay, and the same thing down here, order does not matter, because when we're saying that we're choosing 5 people out of 20 to be, you know, in my team of 5 people, it doesn't matter what order I choose them. Okay, so the order does not matter in either case. So if the order does not matter, remember, if the order does not matter, what do we call that? We call that combinations. If the order does matter, it's called permutations. To permute means to change the order. Okay? If it's combinations, it's going to be NCR. Okay? For some values of N and R. So, how do I go ahead and finish this problem? Well, in the numerator, order does not matter, but we're choosing 5 women out of 13 women. Because the event E is what goes in the numerator, and the event E is choosing 5 women. So that's what goes in the numerator, because that's our event. Okay, so this would be what? I would have 13 women, and I want to choose, using combinations, what? 5 of them. Okay, that's the number of ways to choose 5 women out of 13 women. Order does not matter. Okay, what about in the denominator? Number of ways to choose 5 people out of 20 people. Again, the order does not matter, so it's combinations. I have 20 people, I want to choose 5 people. Okay, and that's it. Okay, that's my result. That's the probability of the event. Let's go ahead and figure out, let's use the calculator just for practice. Okay, so to do this computation, I would just, let's get the numerator first. Numerator is going to be what, 13? And then I have to do the combinations. So math, go over to probability options, and scroll down till you get to the combinations. So I have 13, choose 5. Okay, let's get out of the subscript, close the parentheses. So that's the number of ways to choose 5 women out of 13 women if the order does not matter. Okay, now let's divide it by number of ways to choose 5 people out of all 20 people. How do I do it? I'm going to put in 5 and then go back to math, probability, combinations, and I want to choose, whoops, that should have been 20 people, my bad. Nope. Sorry about that. Start again. So we're going to have 13, math, probability, combinations, 13, choose 5. Okay, that is my numerator, 5 women out of 13 women. Now let's get my denominator. So we're doing 20 total people, and then we're choosing, whoops, not second, my bad, math, probability, NCR, choose 5. Okay. Get out of the subscript by going to the right and then hit parentheses and enter. Okay, and we're getting 0.08301. Okay, and they want it to 4 decimal places, so be 0.0830, I guess, to 4 places. Okay, and that's it. Easy peasy, right? The key is just think about, do we want combinations or permutations? Does the order matter or not? And in this case, the order does not matter because we're just choosing groups of 5 women. There's no special role for the first person or the second person, etc. Okay, it's not like that. It's just regular, just choosing 5 people. So the order does not matter, so it's combinations, not permutations. Okay, easy. Well, pretty easy. All right, let's go on to the next one. Okay, so on problem number 2 here. Again, the scenario is we want all the socks that we draw to be white socks. Okay, so this is the event E that we're looking at. And so remember, the probability of an event E is equal to the number of outcomes or number of ways that give us E, or that belong to event E, divided by the number of ways to get any outcome. Okay, so that's going to be the number of ways to draw. In fact, at this point, you should be able to use the previous result and deduce what this answer is going to be. So you're going to continue this analysis, but if you understood number 1, you should be able to now analyze problem number 2. Okay, so if you're not getting problem number 2 correct at this point, if you don't go ahead and get the correct answer at the end, go back and watch the beginning of the video where we did problem 1. It's a similar kind of analysis. Okay? So I'm not trying to be mean. I'm just trying to get you to start analyzing these more on your own rather than just watching me because you'll need to do that for the test. Okay? All right, so let's go on to problem 3. And actually, before we go to problem 3, I'll just let you know that the result for my version of problem 2 that I'm getting here is 0.1654. So you should be able to generate that result. Okay? Just by analyzing things similar to what we did in problem 1, you should be able to get this probability. All right? Okay, so now let's go on to problem 3. Okay, so on problem number 3 here, it's an interesting problem. So we're going to create a password using 8 letters with repetition allowed. And they're asking us about the probability that no letter is repeated. So what's the event and what's sort of the background situation? So the event is that no letter is repeated. So the event is that we choose what? We choose 8 letters with no repetition. Choose 8 letters out of how many? Out of 26, because there's 26 letters in the alphabet, with no repetition. So that's the special event that we're looking for. Okay, we want that to occur. Now, what's the sort of background situation? What are we choosing from? In other words, remember, the probability of an event is equal to the number of ways for the event to occur, sorry about that, my pen pad's kind of acting funny, divided by the number of ways any outcome can occur. Okay, so for the event E is choose 8 out of 26 with no repetition. Okay, that's the event that we're looking for. But what's the any outcome? Any outcome means, now when we say any outcome, it's any outcome for the scenario we're doing. The scenario we're doing is we're picking 8 letters. So we're just choosing 8 letters out of 26, repetition allowed. Those are all the outcomes. Of all those outcomes, we want to know the probability of the special ones where there's no repetition. So now let's think about how to count each of the numerator and the denominator. Okay, so in the numerator, well, actually, let's do the denominator first. For my denominator, I want to choose 8 letters out of 26, repetition allowed. That means repetition allowed means you can use a letter multiple times. So here's what this would look like. Here's letter 1, letter 2, right? We can just do this, letter 3, letter 4, 5, whoops, letter 6, letter 7, am I going to have room? Yep, wait, look at that, letter 8, okay? So I've got 8 letters I'm choosing. How many ways can I choose my first letter? Well, how many letters in the alphabet are there? At my last count, it's 26, right? Okay, last time I counted. Okay, how about letter 2? Well, if repetition's allowed, then if I choose a letter in for the first choice, I can pick it again. In other words, it doesn't drop down to 25. It stays 26. Stays 26, etc. This is why we said when repetition's allowed, you just multiply the number of ways that each element of your outcome can occur. My outcome is I'm choosing 8 letters. A particular sequence of 8 letters, that's an outcome. How many ways can it occur? Well, how many ways can I pick the first letter? How many ways can I pick the second letter? Third letter, fourth letter? I can just multiply those. I'm not reducing the available number of letters each time because repetition is allowed. When repetition's allowed, we don't need permutations, we don't need combinations, we don't need factorials. All we do is multiply the number of ways each choice can be done, okay, within the outcome. So the denominator is easy, okay? The denominator is just this, okay? Of course, we could write this more succinctly. How? Can I kind of write this in a faster way? Sure, I can write this as 26 to the power 8, not times 8. Don't mix that up, right? 26 times 8 is 26 plus 26, plus 26, plus 26, right? Plus 20, right? You keep adding. So that's not what we want, okay? We don't want 26 times 8. We want 26 times 26 times 26. When you multiply over and over again, that's an exponent. We shorten that by using exponents, okay? So that's my denominator. Now, what about my numerator? Well, based on what you learned from the previous section, 7.4, you should know how to compute, how to choose 8 items out of 26 items with no repetition allowed. Okay? Now, the only question is, does the order matter or not? Okay, it's either going to be combinations or permutations. Okay, so this is either going to be 26C, 8 combinations, 8 items out of 26 in terms of combinations, or 26P8 permutations. Permutations is orders. Order matters. Permute means change the order. Okay? So C means order doesn't matter. So think about when we are, in both cases, repetition's not allowed. Okay? Meaning we're not replacing the item. Okay? So both of these, both 26C8 and 26P8, both of those situations don't allow repetition. Okay. The question is, what about the order? Does the order in which we choose the 8 items matter? Think about whether it does or does not. Does it mention whether the order matters in terms of passwords, or does it mention that it does not? Okay, and basically all I can tell you hint-wise on this one is it's a password. So think about how passwords behave, right? Like if I pick, like let's say the password MATHGOOD, is that the same password as THMAOGDO? Are those the same passwords? It's the same 8 letters. Is that the same password? So what does that tell you about the order? Okay. All right, so this should give you a clue on how to figure out your numerator, and then take your numerator, divide it by your denominator, and you'll be done, right? Fun, 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 right? And you'll be done.